Good morning, friends. First of all, thank you, CRDA, for giving me this opportunity to present on regenerative agriculture, the cotton connection. This is a repeat presentation that I did in Tashkent at the World Cotton Research Conference, WCRC 8. And many of my friends had asked if I could give it again. In other words, they were saying once more. So here I am. Let's get to what is regenerative agriculture and how is it related to cotton. So what is regenerative agriculture? Regenerative agriculture is basically inspired from forests, from the forest ecosystem. Forests are healthy. They have been so for millions of years. We do not irrigate them. We do not provide synthetic fertilizers. We do not spray pesticides. We do not till the forest soils for aeration or weed control. But forests have been healthy and are self-sustaining. So what then is the secret? Let's find out. And scientists world over found out that the secret for a healthy forest ecosystem actually lies beneath our feet, in the soil. In a tablespoon of healthy soil, there are more than 8 billion microbes, more than there are people on Earth. A report published by the FAO also points out that it takes 4,000 years for the topsoil to form. You might be wondering if a forest ecosystem, if the forest soil contains more than 8 billion microbes, how many microbes would a typical agricultural soil contain? Unfortunately, the number could be even 1/100th of this. That means it could be something like 80 million or 800 million, which is 1/10th of 8 billion microbes. So let's see, what do these microbes do? Why are they so important for the forest soil to be healthy, for the forest ecosystem to be healthy? It is interesting that plants release about 40% of the food that they make into the soil. I'll explain this once again. As all of us know, plants capture carbon dioxide for photosynthesis. They make food. But how many of you know that about 40% in a forest ecosystem, 40% of the food that plants make is released into the soil as liquid carbon, and this is the food for microorganisms. Why do plants release this food into the soil? Because they want microorganisms to survive so that the microorganisms can keep them healthy. And microorganisms in turn assist the plants in combating diseases, insect pests, drought, and nutrient deficiencies. And this extensive soil organism network actually determines soil health. And that is what makes a forest soil very healthy. In a typical agricultural ecosystem, it is possible that plants may not even be releasing about 5 to 10% of the food that they make into the soil. That is because the microorganism population is less and the roots sense that. So let's take a look at the next slide. Why is it that agriculture soils are unhealthy? And one of the major reasons for soil degradation in agriculture is tillage. Unfortunately, tillage causes enormous damage to the topsoil. We lose about 24 billion tons of topsoil every year. As a result, our agriculture is becoming more and more challenging year after year. So technically, what is a healthy soil? A healthy soil contains 45% minerals, 25% water, 25% air, but this 25% water and 25% air is because of 5% of organic matter. Microorganisms need carbon-rich organic matter to survive and multiply. The less the organic matter, less would be the air and less would be the water. So in a typical forest ecosystem, this is what one can naturally encounter. But in our soils, in the degraded agriculture soils, you'll find about 2.5 to 3% organic matter, which would reduce the amount of air and reduce the amount of water in the soils. And that is what makes them unhealthy. Of course, because the microorganism population also goes down because of less water and less air. Sir Albert Howard, who is the father of organic farming, coined this term called agroecology. What is agroecology? Agroecology means unhealthy soil produces unhealthy crop. Now that would also mean what he said was a healthy soil produces a healthy crop, a healthy environment, and a healthy society. And this is where the concept of regenerative agriculture starts. So as mentioned, regenerative agriculture forms the core part of organic farming, in fact of natural farming itself. Like I said before, regenerative agriculture is inspired by forests. So let's see what exactly are these practices that constitute regenerative agriculture, because there has been a lot of confusion all across the world as to what this term actually means. So in the next slide, we'll take a look at what it is. There are 6 main strategies of regenerative agriculture. Now, the first strategy is, of course, minimize tillage, because tillage causes soil degradation. So you do not want carbon to be lost. When you till the soil, you actually break those aggregates. Soil aggregates are homes for microorganisms. These aggregates are rich in carbon and it is recalcitrant carbon. So you break open the carbon and microorganisms die and the carbon becomes carbon dioxide. So the first is minimize tillage, or if possible, get to zero tillage. Now the second is avoid harmful chemicals. Harmful chemicals can be, needless to say, harmful to the microorganisms. So anything, it could be a pesticide, it could be a herbicide, it could be a fungicide, it could be any chemical or even a fertilizer. These could be harmful to the soil microorganisms. So first is minimize tillage so that soil microorganisms are protected, and avoid harmful chemicals so they don't die. And the third is have cover crops and rotations. Now, why is this important? Because each crop has its own family of microorganisms that provide services to it. So the more the diversity, the more is your diversity of the microorganisms under the soil. And there is a crosstalk between these microorganisms. One group of microorganisms or one class of microorganisms that could be servicing cotton could also be servicing a crop like tomato. So when you have more crops, you'll have a rich diversity that could actually cater to the needs of the entire ecosystem. And why cover crops? Cover crops, by definition, of course, a cover crop covers the soil, holds the topsoil with the roots, and does not allow degradation by wind or erosion through, through runoff. So cover crops and crop rotations are an extremely important strategy to protect the soil microorganisms. Next is on crop diversity. Like I made a mention, the more crops, the merrier it is for the microorganisms. Monocropping causes the biggest damage for regenerative agriculture, because you have a very limited number of microorganisms and gradually the microorganisms populations get diminished with all our actions too. And of course, what is important is adding organic matter to the soil so that microorganisms can proliferate, they can survive, and they can live better. Having a mulch, an organic mulch on the top of the soil, actually protects water and aeration, which is good for the microorganisms. So that is the 5th strategy. The 6th strategy is animal husbandry. Now this, in some instances it could be difficult, but basically animal husbandry is important because it provides manure, it provides urine, it provides a lot of organic matter to the soil, and in a cyclic manner it keeps, like when animals feed on the grasses, they are actually prompting these soil microorganisms to fight back so that they could support the grasses to grow faster. So these are the 6 main strategies of regenerative agriculture. But as you would see here, everything is linked to how we can allow a better life for the soil microorganisms and how we can avoid any damage that can be caused to them. So what do these microorganisms do apart from helping crops and plants to grow well? Of course, they're recycling carbon. The more diversity and the rich microorganism populations that are present in the soils, what do is they actually fix carbon permanently into the soil in the form of humus and glomalins. These are 2 recalcitrant carbon substances that are fixed permanently. So the richer the soil, more is the carbon that is sequestered and fixed. But at the same time, they are allowing a healthier crop and healthier forest. So what do we have here is a message, a clear message: restore and regenerate soil health. And that is because regenerative agriculture basically is self-sustaining farming. Once you have a soil with a rich microorganism profile, what it does is it will make agriculture self-sustaining, like what it does to the forest. So therefore, regenerative agriculture is self-sustaining farming. At the ICAC, we are harping a lot on three technologies which are already available, but we put them together as practical technologies, as strategies to rapidly rejuvenate soil health. It is possible that within the shortest possible time, you can revive the soil, you can rejuvenate them, you can bring back the soils to life. So what exactly are these three strategies that we are following? We are doing mostly in Africa and also in India. We conducted trainings in Bangladesh and many other countries. But basically the three strategies are biochar, bokashi and jivamrit. I'll quickly get to each of them. But please remember, biochar provides home for microorganisms. It is like ready-made homes, like all these quarters or buildings that we have. Bokashi provides food for plants and microorganisms. Jivamrit, all of you are aware, is a great ancient Indian technology. It inoculates the soils with healthy microorganisms. Actually, Jivamrit proliferates. It enables multiplication, rapid multiplication of good healthy microbes that are drawn from healthy soils in a bucket, and you can multiply them. So Jivamrit is an inoculant of microbial diversity. Bokashi is microbial food. Biochar is microbial home. So these are the three strategies which I'll quickly get through in this presentation. So what is biochar? Biochar is nothing but charcoal produced from plant matter and stored in the soil as a means of removing carbon dioxide from the atmosphere. Biochar can be produced from farm residues such as stalks of maize, cotton, sunflower, pigeon pea. You can make it from rice husk, wheat straw, paddy straw, and from anything. It is rich in carbon, therefore it supports microbial growth in soils. It's interesting that it is like sponge. It's like a sponge. It is highly porous, therefore it improves soil structure and helps to retain water and nutrients. And there is enormous interest today globally on biochar, and this field has rapidly progressed over the past 20 to 25 years. Before that, there were hardly any publications on biochar, but today there are thousands and thousands of them. Now, the next question is biochar easy to produce? Though there are many technologies such as metallic structures, a biochar kiln, or a conical structure which is called kontiki, made of steel material, what we found was that for small-scale farming systems, this method called the ICAC open earth cone pit method works brilliantly well. You can produce as much as about 3 to 4 tons of biochar within a single day and with hardly any infrastructure. All you need is a matchstick, a spade, and some dry sticks. And we have been conducting several trainings all across Africa, and many countries have been producing a lot of biochar. Let's take a look at what is happening in other countries too. There are several technologies and several strategies and several infrastructural material like a double-walled kiln or a steel drum or a steel conical kontiki, which can be used to produce biochar. But we have chosen the cone pit method because technically and scientifically it is one of the best. It releases least amount of carbon dioxide and is the fastest method, the most controlled method to produce biochar, where you are burning plant residues, dry stalks, or any of the dry plant residues in limited oxygen, where it is done layer by layer, and it has converted into an art. And why do I say that there is least amount of carbon dioxide emitted from this? You can imagine ancient Indians were using a conical metallic structure inside temples, inside homes, to perform havan, which is yagya. And you can't imagine why this was being done, because the principles of fire dictate that in a conical structure, when you do a layer by layer burning, the lower layers are deprived of oxygen and the carbon dioxide emission is the least. That is why you can perform a yagya or homa inside a temple or inside the home, because carbon dioxide emission is the lowest. There is a lot of science behind it, but let me keep it for some other day. Now here in this case, Africa has been doing a lot. They have been producing thousands of tons over the past 2 to 3 years with guidance from the ICAC. Now, the next technology is called bokashi. Bokashi is basically a Japanese technology discovered or invented by Professor Teruo Higa. And bokashi composting is the world's fastest ever composting method. It is anaerobic, it's like fermentation. It happens in 3 to 4 weeks. Some people claim even within 2 weeks. You can convert any organic matter into excellent compost within 3 to 4 weeks in a closed system. Now, these closed systems can be anything, which I'll come to it, but what it contains is a microbial consortium, which contains lactic acid bacteria, yeast, photosynthetic bacteria, and actinomycetes. These are known as effective microorganisms, EM1, EM2, EM3, and so on. So Professor Teruo Higa did patent it, and it's also available in the market. You can purchase EM, which is an authentic source and which can be multiplied quite easily at home. Once you buy the EM, you don't have to buy it once again from the market. It's pretty much like curd or yogurt. You can multiply it in any simple sugar. From the ICAC, we have been conducting several training programs in about 8 to 10 African countries, how to produce bokashi. Bokashi composting is important, and technically it is very important when you're using biochar, and I'll come to that. Bokashi can be produced from farm waste, from weeds, from any kind of green matter. In fact, weed seeds die when you are producing bokashi at like during the time of composting. So let's take a look at a few other materials that how bokashi can be produced. Now, this picture was taken at CICR, where we conducted a training, probably for Better Cotton Initiative, I think, where bokashi was produced inside the bucket. You can produce it in any structure which can be sealed airtight. Bokashi is an anaerobic method, and therefore it needs airtight conditions. It can also be produced in trash bags, in 2-3 layers of trash bag. Layer by layer, we add these residues and sprinkle effective microorganisms. The residues can be dry, they can be wet, but anything organic. It can be meat, it can be kitchen waste, it could be anything. But layer by layer, you're sprinkling effective microorganisms over these materials and pack it airtight, and after 2 to 3 weeks, you'll find it becomes excellent compost. Now, this third and important technique is called Jivamrit. I'm sure most of you have already heard about it. Jivamrit is basically microorganisms from healthy soils are multiplied in a bucket. So Jivamrit is rich with soil microorganisms, and it is used as an inoculant anywhere for compost or for soils, or in our case, we are mixing biochar plus bokashi, and then we add Jivamrit so that it inoculates this compost mixture, this biochar compost with teeming numbers and a large diversity of microorganisms. So how is Jivamrit produced? A solution of Jivamrit is prepared by mixing half liter of cow urine in 20 liters of water and 2 kg of cow dung, 1 kg of forest soil, which is an inoculum, and then 200 grams of jaggery and 200 grams of legume seed powder in a solution. So ferment the mixture for 3 to 4 days, and then after that it is ready to use. And I'm repeating again, Jivamrit is used to multiply microorganisms drawn from healthy soils. So I'm repeating this slide again. So these are the strategies to rapidly rejuvenate soil health. Biochar, which sequesters carbon for more than 100 years, bokashi, that provides food for plants and microorganisms, and Jivamrit, that inoculates soils with healthy microorganisms. So let's take a look at how these things are being spread across different countries by the ICAC. From the ICAC, we published a practical guide, a completely pictorial guide. Each page has illustrations, maybe 4 or 5 illustrations, but it takes you step by step how to produce biochar, how to produce bokashi, how to mix them together in what ratios to get the soil healthy. Why is that important? Because biochar is highly alkaline. The pH could be up to 11. So if you use only biochar, it can also ruin the soils and you can lose the battle completely. Bokashi is highly acidic. The pH can be about 3.5. Good quality bokashi you know when it is ready is when the pH becomes 3.5. When you open the container and check for the pH should be 3.5. So if you're adding only bokashi, it can be problematic. Adding only biochar can be problematic. In what ratios they can be mixed to get down the pH to 6.5, which is ideal for many crops, is what this guide does. It also describes details of Jivamrit, so the field application part is also incorporated into this practical manual. Please send me a mail and I'll send you this publication. Now, we have been spreading these technologies across Africa, but interestingly, some countries have taken it quite rapidly, like in Cameroon. This year, hundreds of tons of biochar was produced, bokashi was produced, they were mixed. In fact, they were mixed, added with Jivamrit, and they're rejuvenating their soils. Last year in Côte d'Ivoire, they produced about 4,730 tons of biochar. This was done by Olam. Mr. Mahesh Ramakrishnan was leading the program, and we did some trainings for Olam on the biochar production. Likewise, the technique was implemented in Zambia, where again farmers, reports indicate that at least more than 350 tons of biochar was produced last year, and this year they are producing more and more. So from our side, we are taking this technology forward to ensure that soils become healthier and they can become more productive. Now, as mentioned so far, regenerative agriculture takes care of the soil. It helps the soil to become healthy and revives its life back. But then regenerative agriculture is not just about soil health. It's also about carbon sequestration. And what is carbon sequestration? Carbon sequestration means removing carbon dioxide from the air and fixing it permanently in the soil. So let's take a look at how regenerative agriculture connects with cotton-related technologies in carbon sequestration. So how is regenerative agriculture connected with carbon sequestration? As I was making a mention, regenerative agriculture relies on 6 primary strategies aimed at cultivating self-sustaining farming practices by nurturing soil microbial health, thus supporting healthy crops without extensive human intervention. But it's important to note that of these strategies, 4 strategies demonstrate notable potential for carbon sequestration. The first is the cotton fibers themselves. Cotton fabrics and cotton fibers have carbon fixed in them, and I'll come to the details. The second strategy is production of biochar from crop residues. In this case, the cotton stalks, which are excellent sources, excellent raw material feedstock for the production of biochar. And biochar, please remember, is permanent carbon sequestration. It can keep carbon locked for more than 100 years, whereas even fabrics, they keep carbon locked maybe for about 10 to 20 years, but biochar is probably one of the best. The third technology is on cover crops and rotations, which also sequester significant amount of carbon. Fourth is on minimum tillage, which reduces emissions, which reduces the degradation of carbon, but enhances soil degradation. And with minimum tillage or zero tillage, soil microbial health is preserved, soil microorganisms are preserved, which in turn help in better crop health and better carbon sequestration. And of course, they also sequester carbon permanently as humus and glomalins. Now, these strategies are 4, but there's one more strategy, which is reduction of emissions. Now, all these 5 strategies put together enable better carbon sequestration, but in the case of fabrics and cotton, it is called biogenic carbon sequestration. And I'll explain how carbon dioxide is fixed in cotton fibers. So let us take a look at how cotton fibers sequester carbon. And now this leads to another question. Does cotton have a special place in regenerative agriculture? Yes, of course, it does in terms of the carbon sequestration. Indeed, cotton is a fascinating crop as it produces pure cellulosic fibers using just carbon dioxide from the air and water from the soil. Cotton stalks also contain about 70% holocellulose. This process effectively sequesters carbon dioxide from the atmosphere into the fibers that we wear and the furniture that can be made from cotton stalks. While life cycle assessment studies suggest that the crop may emit about 1.6 tons of carbon dioxide equivalent greenhouse gases per hectare annually. So as you can see, cotton fabrics are excellent storehouses of carbon, and carbon is neatly fixed in fabrics as long as we use them. And thus, the longer we use them, the better it is for the environment. About 64 grams of carbon dioxide is fixed as carbon in a t-shirt of 200 grams if it is used for 20 years before discarding. And the global average in terms of the total global amount of carbon that is fixed is with 26 million tons of cotton fibers that are produced every year, they capture 40 million tons of carbon, thereby sequestering 8 million tons of carbon if the life of the fabric is about 20 years. The average production of cotton is about 800 kilograms of lint per hectare, which is 0.8 tons, and several life cycle assessment studies have shown that to produce 800 kilograms of cotton fibers, each field of 1 hectare emits 1.6 tons of carbon dioxide equivalent greenhouse gases. Now, what is important to know is if we follow regenerative agriculture, how much of carbon dioxide can we capture and store in the soil? Now, capturing and storing, the term is sequestration, both put together. Okay, so cotton fibers alone can sequester 0.28 tons, which is 280 kilograms of carbon dioxide per hectare per year. Cotton stalks can sequester 4.42 tons every year, and these are all based on several scientific studies. I've just produced a few references here. And then with cover crops, it is possible to sequester 1.17 tons of carbon dioxide per hectare, and with zero tillage 1.76. So all put together, it is possible to sequester 7.63 tons of carbon dioxide per hectare every year. Now, when I'm saying sequestration is for 100 years. So every year you are capturing 7.63 tons of carbon dioxide from the atmosphere and fixing them into the soil, whereas your production systems are emitting only 1.6 tons. So therefore, as you can imagine, nearly 6 tons in excess of what you are emitting, that much of carbon dioxide you'll be able to fix into the soil if you follow regenerative agriculture. There are plenty of scientific references, and anyone interested can please contact me. You can also take a look at these slides, and they'll provide you the leads. So is it possible to calculate the net carbon balance or the carbon footprint? A few months ago, the ICAC launched the carbon footprint module in the ICAC Cotton Expert app. The app can be downloaded in iOS or it can be downloaded from Android. It is free. If you type the words ICAC Cotton Expert, you will get it for download, and it is based on artificial intelligence. The module seeks support from greenhouse gas protocols and draws heavily from research papers and the IPCC documents on carbon calculations. It helps to calculate carbon emissions, sequestration, net balance, and thus the carbon footprints instantaneously. I encourage you to please test it and then see what kind of results you obtain from all the inputs that you can gather from a typical farming ecosystem. Now, it's also important to understand that does it really pay to follow regenerative agriculture? There were many farmers that we were working with who would ask, both in India, also in Bangladesh and Turkey, in Africa, in many countries, whether there is a certification system for regenerative agriculture like there is a certification system for organic cotton, and where premiums are paid. Fortunately, today there are more than a dozen companies which certify regenerative agriculture, which verify and certify regenerative agriculture. And this slide just makes a mention, but there are some more that have recently come up. And there are several other companies that, apart from verification and certification, also enable payment for carbon. Please remember that 1 carbon unit means 1 ton of carbon dioxide. And from every cotton field, you can get benefit of at least 6 carbon units. And these payments are in operation. In India, there are also companies like Bhumitra and a few more, but internationally, there are several companies that are already operational, and they pay those who fix carbon, and they charge from those companies that are emitting carbon. So it is offsetting, insetting, but this has become carbon trade. So who pays for carbon offsets? Uh, there are several companies that do it, but most of the companies that emit carbon are the ones that pay for it. It is almost like redemption. It is, so this is just a list. It could be airlines, it could be oil companies, it could be mining industries, anybody, any company that is emitting enormous amounts of carbon dioxide pays farmers who are fixing carbon permanently into the soils. Not only farmers, anyone who is saving carbon or has very low like emissions of carbon below the cap, they are paid. But the companies that pay are the ones who are emitting. Now, it's also important that you need to understand how much of payment can be made. Please download this book. And of course, there are many other publications, but if you type these words, removing carbon now, it was published by Oxfam probably in 2020, but you can download it from Google. You'll quickly understand the power of carbon payments. So I encourage you to download it. Now, I'd like to read this passage from the book published by Oxfam. Estimates range between $90 per ton of carbon dioxide and $120 per ton. Now, 1 ton of carbon dioxide is actually equivalent to 1 carbon unit. And as I was explaining earlier, about 6 carbon units can be easily captured per hectare if, if you're good enough with your carbon sequestration. Now, this rate of US $90 to $120 per ton of carbon dioxide can be obtained for producing as much biochar as needed to remove 1 ton of carbon dioxide. About 300 kilograms of biochar will give you 1 carbon credit, approximate calculation, which contain 272 kilograms of carbon. The world market price for biochar is currently between 500 to 600 euros per ton. Since biochar sequesters about 3 times more carbon dioxide than its weight, this would translate to a price of 166 to 200 euros per ton of carbon dioxide captured if the whole cost of biochar production was paid for by carbon certificates. Carbon certificates from biochar are sold today for 100 to 150 euros per ton by one company in the United States. So this is the last one slide, and the key messages are: create regenerative soils to increase yields, enhance carbon sequestration, enable carbon offset payments, and of course, help small farmers to combat climate change. And that was my last slide, friends. My apologies, I'm not really available online to take your questions, which I would love to, but I'm sure I'll be coming to India, and there may be occasions where I should be able to meet you, and I'm looking forward to that. So finally, this is the last slide. Thank you, farmers. And thank you to all of you for your patient listening, and thank you, CRDA. Thank you, Dr. Chauhan. Thank you, Dr. YG Prasad. And Dr. Sandhya helped me a lot in this presentation and in my journey to Africa and in all the trainings that we conduct together, and of course, all through my life. Thank you. Thank you, everyone.